They came from Mr. T. But if you look at Maggie's foot, yeah, she shouldn't be here. Ankle specifically, I think, right? Okay, what do you guys notice? We're picking up where we left off yesterday, the FRQ that was graded for the first point, which technically up here they just labeled as L'Hopital's rule. Last year I would have given you that if I had seen a derivative over a derivative and something indicating 0 over 0. Specifically, what do they need? The top limit to be 0, the bottom limit to be 0. Separated, right? And if you didn't separate them or somehow show them separately, they would not have given you the point because both requirements need to be true. The second one also needed to be true, which was clearly attempting. Doesn't mean that the derivatives had to be right, but just attempting. That's also kind of encouraging because some of you guys make mistakes on derivatives now and again. So you could have gotten a 1 point even if your derivatives were wrong because they saw you using L'Hopital's. What did they not make you do? State something about differentiable or continuous, which will be interesting when we look at last year's. How about the next one for the answer point? Correct answer. Did it need to be written like this, though? No, you could have boxed it way back here. But it definitely could not have just been that. You had to actually find the solution, right? Correct answer, correct derivatives. So if you had made a mistake in your derivatives and somehow magically still gotten the right answer, that you would have not gotten that point. And limit notation, limit notation on the ratio of derivatives. Now I hope this isn't a BC mistake, but I saw it in AB. I will see it. I do see it in AB a lot. Saying this equals that. Does it? No, which is why I always forced you to keep rewriting your limit, right? So right here it says if you did not write limit notation somewhere with the derivatives, they didn't even make you do it every step of the way, even though you should have. But somewhere with the derivatives, you would have lost the answer point, even if you got it perfectly correct. Hey, look down. What if you didn't write a limit anywhere? No points. All notational errors or linkage errors come off the first point. All notational errors or linkage errors. What are they talking about? Pretty much here. That was actually I think that was technically the first year maybe? I think it was the first year. What a lot of us AP teachers didn't realize, actually this was released by the head, it doesn't actually show his name, does it, anywhere? By the head guy, like the head guy, like the head reader. Here. I'm passing it off to someone else, yeah.
So I just had kind of like a hypothetical theoretical question about the rewriting the limit. So I was wondering about this from last year. Like whenever we do a derivative normally of the limit, like it disappears and it turns into a little bracket.
A derivative?
So like where you were saying you have to write the limit as x approaches the derivative ratio as well as the derivative ratio. So I've always wondered why, because like when we do like a normal limit, like any like f of x minus.
We have to keep rewriting until we're evaluating the limit, which means we're plugging in.
So deriving it, so when we normally derive it, isn't that evaluating the limit? No.
That's restating the question to an equivalent expression. Right. Does that make sense?
Yeah. Is there a reason why?
Yeah, because depending on where you're headed, that expression will equal many different things. And it's possible that there is a point at which the function will not exist, but the limit still could. And that's the exact same linkage error as saying equals 0 over 0. Does that make sense? Yeah. What do you guys think the scores would be on the first one? Is the numerator going to 0? It's the denominator going to 0, and then the limit is being written of a correct derivative, and it equals the correct answer. What do you guys think they would have given number 1?
No, because we didn't have a limit.
They didn't show limit, they just said approach. But wait a minute, doesn't that mean approaches? I wonder if that indicates limit. They got the full score. Why?
That's so cheap.
No, it's not cheap.
How does that mean?
What is a, wait, but what is a limit? A limit is stating what the function is approaching. So look, it's another way of stating the limit. Function approaches 0. So do you have to necessarily write out the word limit 2 different times on each of the numerator denominators? No, they're saying, oh, hey, if you're using an arrow, we get it.
That seems risky.
It does seem risky, though.
But
I know.
If they just did that,
Some teachers are probably teaching them this, though. I'm trying to see, is there any place where, because I thought, but then I think it's too risky, so I didn't. I thought if you had the entire limit written, having you guys do an arrow to 0 on top and an arrow to 0 on bottom, but from the seminar I went to, it sounded like that was too risky, so that's why I'm just not doing it. But the problem is they didn't actually show one of the solutions doing that. Because I would have actually, instead of having you guys write equals 0 over 0, I would have done arrow 0, arrow 0. That's what I thought would be okay, but I don't want to get you in trouble. All right. And
so for that one, if they did like just the thing in parentheses equals 0, that would have been wrong.
Right. Because the function doesn't, the limit does, so that's why the approach needed to be there. Okay, how about the second one? They're doing a great job, right? That's the derivative. They get the correct answer. There's the limit, but what didn't they do? So what do you guys think? They lost the using L'Hopital's rule. Not because they didn't take the derivative. They took the derivatives top and bottom, but they didn't show that, hey, it's valid to use L'Hopital's, because L'Hopital's is only appropriate when you get an indeterminate form. Does that make sense? Yeah. So they got the second point for the answer, but they missed the point in the beginning because they never stated about how the top and bottom equaled 0. I mean, you guys can kind of see the scores of the other ones. Let's try to figure out why. So we have another 0, 1, 0, 0, 0, 1, 1, 0, 0, 0. Uh-oh. Poor number 7. Oh, they didn't put a, yeah. What was the mistake here? It's us, right? Why is it a linkage error, though? Now, I would have never told you to write an equals after the 0, 0. I wasn't that bad, right? Because 0 over 0 does not equal this. That's not true. But I did have us writing equals to be like, oh, if you were to solve, it didn't work. So maybe if I had you put a line through it, but then they would still take off the points, because if you put a line through it, they have to ignore it, and ignoring it would get you the same points as this. So I can't even have you write equals 0 over 0 and put a line through it, because technically you haven't done the analysis correctly, at least. So this would have been us. It would have been 0, 1. Because your answer was correct, your derivatives were correct. There's the problem. This one got 0, 0, I think. How come? No. True, but actually, why'd they get 0, 2? The main reason? No limit written. But you're right, the whole equals 0 equals 0. But they didn't write limits, and they said automatically no limits. Forget it, 0 over 0, keep going. Oh.
What if somebody just wrote, like, since the original limit produces an indeterminate form, like, isn't that the same thing as, like,
yes, and so they're just giving us answers based on kids not usually writing statements. So these aren't the only possible answers. These are just some of them. Mm-hmm.
So for the one that just did the derivative, if he'd written since the original limit produces an indeterminate form, he would have gotten both points.
But like
number
instead
2.
of writing C, you could write at 4.
Yeah, he could say since the original produces an indeterminate form. That would be appropriate.
That would have been both points.
Mm-hmm.
Oh, I'm just going to do that. It's so easy.
What if he blanked them?
oh no.
But like, it's the same logic. All you have to do is write it down instead of trying to show it.
Let's look at last year's, though, before I totally let you loose on that one. This one.
Did you skip this stuff?
What do you miss?
Show the person.
He didn't show the, going to 0 part. So he's going to miss the first point for that. So it's going to be 0. But why did they give him the second point, even though he didn't rewrite the limit? It just said it needed to be written in the derivative step at some point. So they actually gave a little bit of grace there. As long as you put the limit somewhere with the derivatives, we'll take it. I think that's risky. I would never have you guys like purposely do that. But anyway, just for you to know, heads up. This one. Approaching. Good so far? Because they're being snazzy like that. Derivative was fine, but what did they not put? Pi. So they got 1, 0. Because they got the answer wrong, right? But the analysis was good. And then this one, 0, 0, because they didn't do the going to 0. They took the derivatives perfectly, but they didn't put the pi. It's just reminders, right, of how even if you have the concept, you could still get no points on the FRQs, which some of you felt very much on the mock exam last year, because you're like, I thought I'd get some points. But you realize they have to take off from mistakes, and those mistakes can take away from the very few points that are already being offered. Okay, that was on the FRQ from last year. No, sorry, from the sample one from 2 years ago that hadn't really been explained to teachers, unless you happen to go to a seminar right after that one was graded. Now let's go ahead and look at the 2018. I think that was probably BC the first year. I actually don't remember if it was AB or BC. We're looking at AB, though, because that's the one that you guys did last year, and you had a L'Hôpital's. And this is the one that was highly debated at the seminar. Like, teachers were mad over it. And I understood why. I don't get mad, I just get frustrated. I get mad, but I didn't at this. Where was it? Where was L'Hôpital's? This one? No.
Okay, move, Kathy. Move.
Yeah, same.
Oh, this one, right?
Yeah. I just lost it all over summer.
No, it's math in general when you're not practicing it. And it's kind of the same for other STEM also, right? If you're not, like, in it, it's not going to be sharp.
When I started doing the summer work, I was like, what's an integral? And then I had to look at my cards.
Oh my goodness. But it was so second nature, right? Yeah. Yeah, no, me too. Like when I started teaching calculus, I hadn't taken it for 3 or 4 years since college. And yeah, I had to relearn it all. I was like, wait, what? All right, kiddos. So letter D, right? Differentiable function such that g of pi over 2 is equal to 0. Okay, fine. They gave us a statement. Why is that statement important? Because we're about to take a limit, and you would plug in, and we would have it going to 0, right? We also need to talk about f. F is the original function. So what did you guys probably write last year? Equals 0 over 0, and then equals the limit as x goes to pi over 2, f prime of x over g prime of x, and hopefully you went ahead and then properly went equals and plugged into the derivative that you found up here somewhere, and then plugged into g prime of pi over 2, interesting, which is not differentiable at pi over 2. Well, g prime is not differentiable, but is g differentiable?
Yes.
Yes, because the point exists. G prime is continuous, g is differentiable. Interesting. Let's go down and see how, oh, that's not the one that I wanted. Sorry, Lucinda. Scoring guidelines. Was it the last FRQ? Oh, no, second to the last. Okay, what do you guys see? You see them splitting up? See them splitting up? This looks all well and good, but look at the points. No limit notation. You could have gotten 1 point. But you couldn't have gotten either of the L'Hôpital's or the answer points. Why did they give an extra point up here? Part of that point is the separate numerator-denominator limits equals 0. Do they think that's important? We get that by now, right? Part of it is each of the limits equaling 0. But what's the other part? If you did not state literally that g is continuous at, now if you said differentiable, guess what? They didn't give you the point. Even if you had said differentiable off of the forever card. That's what teachers got really mad at, and I was one of them. I got frustrated. Because we were like, we've taught our kids differentiability implies continuity. But they were like, no, based on the nature of the function, they had to specifically state to have their proof be seamless. Why? Why? What's weird about this example that if you did not state that, you might have been wrong? Because they're always think about the multiple choice. Aren't they always thinking like might be versus always? Like, oh, it's sometimes true, but versus always true. Like there's a big difference between those two, right? They're always trying to trick you on that whole like 1 and 2 and 3, 1 and 2, 3 and 2, etc. So right here, they're saying this step is needed to be explicitly stated because of something in the function that might have made the answer this, but might have also made it something else. So going back, let's go look. There's a sharp point.
But differentiable is always continuous.
Yes, and that's what many teachers were also saying. I know. I agree with that also. But let's check out why they were trying to be so particular. G didn't even show up earlier at any point in time, right? No. Okay. the question stated, let G be a differentiable function. According to our forever card, that is enough to say L'Hopital's applies. True? This is G prime, which has a sharp point. What could be going on where G prime seems to exist, but G's in trouble? You could have some funky piecewise that could redefine it at a different point. That's the only way that I can think of it not working out. It could have been a weird funky piecewise, which is really dumb for them to talk about. But the secondary issue, the secondary struggle is differentiability. Our card is not wrong. If a function is differentiable, it will always be continuous. So here's the dilemma. What are the AP guys saying is more important to say or to prove than even differentiability? Continuity. Because this one is parabolic on one side and linear on the other side, this one does come from a piecewise function. It has to. It could be like an absolute value, something flipping up, but even then it wouldn't be linear on one side. So it is coming from a piecewise. And so they're saying there are a lot of things that can happen in piecewise functions, and so that continuity is the most crucial part. How does that actually translate to our forever card?
So what's the problem that's not stating that?
L'Hopital's doesn't necessarily apply.
But in their answer, since they did state it, then it's fine?
Teachers were arguing that too. But in their mind, they were saying, based on the piecewise original nature of G, if students did not state the differentiable, which thus implied continuous. Because that's what they said in the work, right? Oh, I already took it off. But yeah, it said differentiability implies continuity, therefore this is true. So they're saying that if you didn't actually state it, whether or not you thought it, sorry, my sound's on, whether or not you thought it, they couldn't tell. And there's the possibility that L'Hopital's...
Basically just restate what they already told you.
Yeah. And here's the bummer, too. No, it's not a bummer. They did say justify. Which, I know. But hold on. You guys know justifying, sign charts, etc. We have to put into words what we see so naturally. This one stinks because they stated, I don't want that one, because they stated differentiability. However, hold on. I don't think this one said justify, did it? Just thinking about the difference. This one doesn't say justify. So this one, there was no need to even talk about differentiability, continuity, any of that. If it doesn't say justify, you're good. The problem is justifying L'Hopital's, not just with your work, but with your words. And that's why they took an extra level of, like literally extra level of expectation on your answer. Now, I'm trying to find...
Wait, that was AB?
Yeah, that was your guys's.
Oh.
Because L'Hopital's is on both exams, right?
Yep, I devolved. I actually devolved. Can we do that one, please? Like,
where is... Here we go. Sample responses. The chief reader report, that's the guy I was talking about. He would definitely talk about that one. It was like the main one that all the teachers were like, what the crap about last year? There might have been some more colorful language. So, we're talking about letter...
It's like Arya's work or something. That'd be so funny.
That would actually be pretty funny, I won't lie.
Do you put that you want them to have your answers?
I don't remember. I think I said yes, but
We've already
I don't
seen
think
that.
they'd use mine, if they could even read it.
Okay, here's A, B, C, D. Okay. Note, limit of G equals 0 since... Ooh, look at this kid going above and beyond. Little stinker.
That's continuous.
Also, f of pi over 2 is equal to 0, and f is continuous. So the limit equals, yeah, this kid was going off.
I really understand.
So by L'Hopital's. This is a little wordy, though. It's not very concise, but he's like making sure everything because of the justify. It could be a she. I don't mean to. I think it's a he looking at the writing, but I might be wrong.
They got that point.
Now, checking out that was sample 1. Okay, we'll see what his score was in a little bit. Sample 2 looks great, right? Except, was there anything about the indeterminate? No. And the limits being 0 for the top and the bottom? No. There was like, hey, look, I'm showing my work. That's justifying, right? But there was literally no words about L'Hopital's being applicable.
They underline the g prime of, or g of pi over 2 equals 0. Does that mean anything? No? Okay.
I mean, that's the reason why they did this down here. I see what you mean, but they never talked about f being 0. We can see if they gave him any bit of grace for that, but I doubt it. The underlining, I doubt.
Oh, I always underline stuff.
No, that's good, but they won't give you points for underlining. Does that make sense?
I underline everything just to help me.
This one, that's nasty. That's not good.
No. Never that.
Poor kid. Oh my god.
Let's see the notation. Like that's a huff.
Oh, they got it at the end. They just did it separately, but they never
But
connected it.
and they wrote a limit with the answer, and they never did the primes, and
Who says?
Lisa just said that's his.
literally, no.
Oh, what about?
Okay, let's check it. Letter A, letter C. Where's letter D? Ah, okay. See how much words are spent on letter D? Like, they're trying to prove a point. Like, they're making a point with you guys.
Why don't they ever just budge? They're so stubborn.
It is given that G is differentiable. Yeah, that's great. We read that. G pi over 2 is 0. The graph is supplied. Define the value of, if it exists, to justify. A correct response should start with a confirmation that the requested limit is an indeterminate form. So, Aryan, that's why I'm thinking your words are sufficient. To which L'Hopital's rule, the hospital's rule applies. The numerator has limit 0. We got that.
Wait, they didn't even say it.
Because G is differentiable, it is continuous, so the limit of the denominator. Here's the problem. I didn't even realize it until I just read it. The continuity wasn't necessary for L'Hopital's. The differentiability was necessary for L'Hopital's. What did they say you needed to state continuous for? Just the limit to be what you said. It all had to do with the limit. Because the limit only exists if the function is continuous, right? Because both sides have to agree. So the struggle is they weren't even talking about the continuity being necessary for L'Hopital's, which makes me feel better. We don't need to change our endeavor card. But the struggle with them is they said that limit isn't what you think it is unless G is continuous. So the reason why they didn't take differentiable wasn't because they were saying continuity is required for L'Hopital's. Differentiability is it's okay, it was stated, you're fine. What wasn't fine is unless you took that to mean this, you stating the limit existed wasn't necessarily true.
Because all they gave you was G of...
They're all about having a perfect argument from beginning to end. So then what was the scores? This guy got a 9 out of 9, so he was totally good, the guy who wrote a whole paragraph. The next guy got a 6 out of 9, and he lost points. He got only 1 out of the 2 points. No, 1 out of the 3 points.
Wait,
No, it's part D. Sorry. 2 out of the 3 points. Yeah, 2 out of the 3 points. And down here they said in letter D, they didn't say G is continuous. And they also said and, but you guys know if one thing is missing, they're not giving that point. And then poor little guy, number 3. He probably didn't get the first point. What'd they say?
It said no.
No points, yeah. He didn't. Poor guy. Which is sad because he got the right answer. But he made a lot of mistakes along the way. You guys realize that maybe these sample responses coming from FRQs with justifications that you're a little bit shaky on could be really good to read? You see what we just did with L'Hopital's? And I know L'Hopital's, like you would never think of going and checking out L'Hopital's. I only did because when I got in there, I was like, oh, you're kidding me. 0 over 0 isn't enough for your equals 0 equals 0. Like most of the teachers in there, if they hadn't already been to a seminar, were the exact same way. Bummer. However, for other topics like justifying maximums and minimums, or for justifying absolute extrema, or for even Euler's method, if you want to go check out that one, like it'd be good to go find, you can even search like Euler's method FRQs, they'll point you to a year, you can come check out exactly like, hey, here's a high score, middle score, low score, and here's how they or why they graded what they graded. Does that make sense? Okay.
Kind of stupid question, but
That's
if
okay.
they release samples and they release the questions, why can't we see our own tests? I don't get that.
The work slash the money slash the availability, in some way, shape, or form, all of those combined are a reason why not.
So there's no actual issue. They're just really cheap and lazy.
Hey.
I mean, it's College Board. I'm not holding back.
Multiple choice is a whole other ball game. Multiple choice they're very particular on, and they're very stingy on, because it's very hard to make multiple choice questions, brand new questions every single year. So their multiple choice would never be a back. FRQs, I think it's mostly to do with they don't want to force their graders to go through the process of grading it the way a teacher would, to try to give you like a full analysis of your score. So they're doing very little work when they're grading this, because it's not going anywhere. It's not going to anyone. But they do have, like what you just saw was the head grader's part of his presentation to the tables that were grading that specific part of that specific FRQ. So they're giving them a lot already, and they have like the table leaders and then the room leaders and then like this whole crazy hierarchy as far as like making sure that the grading of the exam is as objective as possible. But I think that's another reason, is because there's barely any writing on it, and it would just be throwing out.
Like, do they even need to write the explanation? Because we can see the explanation online.
To some extent, they want to make you work for it, which isn't completely unheard of.
I just want to know like which points I got, and which ones I didn't. So like I would
I
be
understand.
satisfied with like X's.
But most kids, like I was an English teacher for a whole year, and I would work so hard on essays and like grading essays and explaining why I'm not giving points for this, that, and the other with a rubric, etc. I would hand it back, and over 3/4 of them go in the trash.
Yeah, because it's like if we want to know the reasons, we can just go on here. I just want to know.
Right, but what I mean is, they don't want to spend all this money and take all this time and etc. to get all these things back to these kids when over 90% of them end up in the trash. You know what I mean?
That's true.
So it would be helpful for maybe 10% of the kids, maybe 5.
Why don't they let us request it then?
That's a good question. I don't know if College Board has like a
Lawsuit.
submission. No, not lawsuit, but I mean SAT doesn't submit anything. You could go through all the standardized testing. But since these are released, like it's a valid question, it would take extra people, extra work, extra money, more expensive exams. Like it just goes from there. Justin, I think you have a question, but we're going back. We're just going to play with L'Hôpital's. We're going to start improper. But let's just play with L'Hôpital's. But what was your question, bud?
I was just gonna ask, like, was that like the top of the hierarchy? Like, is it Salcon or?
No, the chief reader. Oh, what was his name? Mm-hmm. But even like the chief reader has like there's like a board that deals with what's actually the content on the exam. Like it's this whole. But the chief reader is the one who's basically the guy you go to if no one else knows the answer. That's who that guy is.
Are there separate boards for A, B, and BC, or is it just one board?
No, calculus is one category. I mean, they probably have like some sub head of A, B, and BC, but I don't know. The chief reader. The chief reader, which is an elected position that must be turned over every 3 or 5 years. So it is no set one person.
So are they like elected by Salcon?
Why are you curious?
He is not in charge in any way, shape, or form.
Just like an interesting figure. I don't know.
He's just pulling all the strings behind the
Yeah.
scenes.
X equals X minus sin X
Loki,
should be
the
X equals
proletarian
X
leader.
should be
No, you don't have to name him.
College board.
So like if I'm writing it, I have to put element goes to 0 of X. I can't just put X of X.
Oh, I see. Like if you want to shorten it.
Yeah.
No, you could do that, I suppose.
Like
Something like this, you could do that.
okay.
You could do the limit. Or you could just, like f of x, g of x, you do name it.
Yeah, okay.
So then you could do if f of x equals 0 minus 0.
Or you could just write limit sin X minus sin.
Yeah. Why don't you need to state that both of these are, I mean, like if it was a full FRQ, they said justify. Why wouldn't you need to state that x minus sine of x is continuous and x cubed is continuous? It's the nature of, the functions. Of course they're continuous. That was never a question. But the one that we had was a weird piecewise. So the same reason they don't need to make you defend why 2 squared is 4. You wouldn't need to defend that the limit as x goes to 0 if x minus sine of x is 0. It's straightforward. It's obvious. It's algebraic. Now, do I literally want you doing this in homework necessarily every single time? No. No, I don't. We're just going to change a little bit as to how we show it the short way. But long story short, are you guys rewriting your limit like you should? Yes, hopefully. Take the derivative over take the derivative. What's the struggle? So how are we going to do the shortcut notation because this isn't an FRQ? And I don't think they would give you an FRQ where you had to do repeated steps because that just gets tedious and annoying. For shortcuts, what are we going to do? Is that cool? That way we're not writing equals with a 0 over 0, which is technically a lapse in logic. We can go going to 0 for shortcuts. That's okay. That I don't mind. For an FRQ, we go above and beyond on FRQs anyway, hopefully, right? So what happens is you keep going. Equals is appropriate, and minus 6 is the final answer. Double check my signs, though. Was that good?
Yeah.
Okay. Are we okay for how to do it the shortcut way? Not equals 0 over 0, but going to 0, going to 0. Couldn't we similarly say going to infinity, and be correct? Like if it was another problem that had an indeterminate that needed L'Hopital's. Yeah, that would also be okay. This one is so straightforward, let's not. You guys are BC. What about this one, though? Because you're going to have some interesting one. And since the homework wasn't posted last night, I'm just going through examples. Improper integrals, I think we'll be okay on. I might post a quick little video on your Google Classroom so that we can go a little bit faster on Tuesday, if you guys don't mind, about improper integrals. Do a little Mrs. Leon magic. Not magic, but... Flip in the classroom. Can we do equals 0 over 0? Sorry, 1 over 0 minus 1 over 0. Can we say that? No. Not technically in or with regards to. But could we? If we're not quite sure where we're going, what we're headed to, how to show it's indeterminate, could we do a 1 over 0 minus 1 over 0 and then tell them to ignore it? You can do that in an FRQ. You can say ignore it. They can't look at it. They can't take points off. But here's the long story short. Is this a 0 over 0 or infinity over infinity? No, it's indeterminate. I'm stuck, but I have to somehow rearrange. Aryan, what should I do? It would be infinity minus infinity, which is indeterminate. For Justin and I were talking about it. Who's greater, who's stronger? Is it 0? Is it infinity? Is it negative infinity? So it is indeterminate. We're stuck. But L'Hopital's needs 0 over 0 or infinity over infinity. It needs that. Find a common. Yeah. Why don't we make it x minus sine of x all over x sine of x? Okay, yeah, it's going to be a product rule. And let me give you another heads up. It's going to take a couple iterations. It's going to take you working on it a couple times. But you will get there. You're going to have to do product rule a couple times, but you will get there. You guys okay to do ... and trust me and then work on it in homework when you get there?
How's the homework on?
I don't know, it's similar. It's similar. Just because we only have a few minutes left. I can actually post the video from last year and with each of these examples worked out. That's actually a good idea. I'll post that in Google Classroom underneath this assignment or with it somewhere. It is a special limit. But why do I still have it in your notes if you should be able just to answer it and say that the answer is e to the... But what proves that? Justin asked me yesterday, why is it true? What proves it? L'Hopital's. Why? Because if I do 1 plus 1 over infinity to the infinity, question, isn't that 1 to the infinity because that goes to 0? 1 to the infinity is indeterminate. So then we go ahead and do this little like x to the infinity of x plus 1 all over x to the, well, that didn't help at all. What's the long story short? I need to get the x down. ln. ln, but we don't even have another side. Come on. Been in calculus long enough. We make another side, right? So can't we go ahead and say something like y is equal to 1 plus 1 over x to the x, taking the limit of both sides? I can take an ln of both sides. Properties of limits, the ones that we forgot and ignored and didn't really care about. You can bring the ln in. You get the limit as x goes to infinity of x times ln of 1 plus 1 over x. Oops. Hi, bye. I don't know what's going on. I think he's in choir right now, though. Is that what it is? Aryan, this is right now infinity times 0. How do I make a fraction? It was a question you asked me yesterday. If it's a multiplication, how do I get a division?
Oh.
Yeah. Yeah. Now I end up with 0 over 0. Ha-ha. 0, 0. Take a derivative. Oh, no, that's disgusting. Rewrite your limit. 1 over u times u prime. Isn't that just 0 minus 1 over x squared? Hey, what's his derivative? What's the final answer? Isn't 1 over x going to approach 0 as x approaches infinity? And 1 over 1 is just 1? 1! No, the answer is e. What? Wasn't it ln of the limit? How do you get to the limit? Ha! Woo!
So y could be f of x, right? So then if we would come full circle limit.
Yeah, come full circle right back to the very beginning. Just a quick reminder, you actually saw it last year, but some of you were just kind of like,
I'm silly.
What about this guy then? Zero times ln of 0. Isn't that just 0 times 0? What's ln of 0? What's the limit? ln of 0 does not exist, but what's the limit as x goes to 0 from above of ln? Negative infinity. What's 0 times negative infinity? Indeterminate. How?
ln x over.
Oh.
That's a hack.
It's a good trick. If it works.
Press X to down.
But wait. Isn't that going to negative infinity? And isn't that going to?
That would also be,
Still an infinite over an infinite. It'd be positive infinity, right? Because those are all positive. Riley, it's legal because multiplying by a fraction, we could make it over 1, is dividing by its reciprocal. So we normally go this way. Over 1 isn't there. But we can also put it over 1 and go that way.
Like x to the 1/2, and if you make the exponent negative, it just goes in the denominator, which is what you did. So it's just x to the negative 1/2.
Oh, that's an interesting way of thinking about it.
If it was the regular x.
Yeah, it could just be 1 over x, but this one's 1 over square root of x. But I'm still flipping it. Yeah. It's still indeterminate though, right? But I can at least take a derivative. Wait, is this good? No. What should I do first? Bring down the negative 1/2 power, right? Now it's going to be that to the negative 3/2 power. Am I scared about just a few of you and being able to simplify this? Maybe a lot of you and being able to simplify this. I could rewrite him to be x to the negative 1/2. So I brought down the negative 1/2. Negative 3/2 puts them down there. How do I simplify? Yeah, I think I would. So then we would have 2x to the 3/2 all over negative x. What do I do when I have like bases with exponents? Subtract. So 3/2 minus 1 would be 1/2, right? Negative 2 square root of x. Hey, can I do that one? Do you need to play with Whoopie towels? Yes. What are we not doing? Equals. 0 over 0, or infinity over infinity, or 0 times infinity. We're not doing equals. If you want to write it to remind yourselves, just put an x through it. And if you're trying to show it, do arrows. Sound good? Peace. See you guys later. Yeah. Due on Tuesday. We'll work with 9-3 on Tuesday. But I might post some stuff in your classroom, but you guys get notifications, right? All right.
Thank you, Missy.
Bye, guys. You're welcome. You're welcome.